Hello and welcome to your algebra recording for the week of September 19th. We are also in week 6. So make sure that when you go to do the key phrase assignment today, that the date of the key phrase assignment, it matches this week's date. Which reminds me to remind you to make sure that you've got your math notebook out and that you're ready to take notes as you watch the recording. And you're taking those notes so that you have something to refer back to when you do this week's assignment, and so that you are focused more when you are taking notes on the recording. And we're going to start with the warm-up, something kind of new that, some new content that we're looking at in the warm-up. But what I want you to do is take a look at the warm-up question. And it says, state whether each word or phrase represents an amount that is increasing, decreasing, or constant, meaning staying the same. Oops, I kind of gave away that first one. So what I want you to do then is look at the list of words and decide whether each word represents increasing, decreasing, or constant. And that's going to get us introduced to what we are going to be focusing on this week. So at this time, I do want you to click pause and try the warm-up questions in your math notebook. And then when you're ready to check your work with mine, go ahead and click play. All right, so we've got 3 words, increasing, decreasing, or constant. So we can use those 3 words to help us decide what the words below represent. So stays the same. Would you say that that represents an amount that's increasing, decreasing, or constant? So if you said constant, you are correct. So something that stays the same is staying constant. What about rising? So rising is another way to say increasing. Drops or falling, those are other ways of saying decreasing. And slows down, that also represents decreasing. The opposite of that would be speeding up. That would be increasing. So just some words that can be represented with other words. And knowing these keywords and what they represent is going to be helpful this week. And this week we are diving into Unit 2, where you're going to be learning about relations and functions. So things that you're going to be learning about is graphing relationships or certain situations, which is why we did the warm-up. You'll see that in just a bit. You're going to learn what a function is and how to determine if an equation is a function. So these are just some of the things that you're going to be learning this week. So this is stuff you're going to be learning this week. So let's jump right in to graphing relationships. And continuing off of that idea that we just looked at in the warm-up. So when we have situations, we can create a graph to represent our situations. And an example of a situation where we might create a graph is looking at you right now on this slide. So that situation says, the air temperature increased steadily for several hours, then remained constant. At the end of the day, the temperature increased slightly before dropping sharply. Choose the graph. Well, we aren't going to choose. We're actually going to create a graph on our own. So we're going to create a graph that represents this situation. So we need to look for some keywords. So I made a table up over here for the keywords, and then we're going to talk about what those keywords mean. So what are some keywords that, as we read through this situation, will help us create a graph? So let's read through it again. The air temperature increased steadily. Okay, that's a keyword, something that the temperature increased steadily for several hours, then remained constant. So we're looking for keywords that tell us about different types of movement. Are we increasing, decreasing, or staying constant? So let's continue. At the end of the day, the temperature increased slightly before dropping sharply. Okay, so there's our keywords. We got them all highlighted, and let's write them down in this chart over here. Let's change color. So the first keyword was increased steadily. Increased steadily. What is the next, and what does that mean? Let's just talk about what does that mean. So increase steadily means that we are increasing, right, at a constant rate, so it's going to look something like that. The next term we saw was constant, that then the temperature remained constant. So that means we're not increasing or decreasing. We're going to have, a horizontal line to show something's constant. Then we have increasing slightly, so we know that that's going up again, and then we have dropping sharply. So dropping sharply, that keyword tells us our graph is going to be decreasing at a pretty quick rate. So let's put that on a graph. So we are graphing the temperature compared to time. And time always goes on our x-axis, by the way. Whenever we've got a any type of time, that always goes on our x-axis. Remember, our x-axis is our vertical axis, or our horizontal, I'm sorry, and our y-axis is our vertical axis. So let's graph this situation. So we start at the beginning. The air temperature increased steadily. So as we move through time, we're going to move to the right. So here we're starting, and the temperature increases steadily. So it's increasing at the same rate. It's not increasing and then steadily and then really quickly increases. It's just steadily increasing. So we're going to have linear line here to show that it's increasing steadily for several hours. Then it remained constant. So to show something is constant, so that means the temperature is not raising anymore. So it's going to stay at that same temperature. So we're going to show that with a horizontal line. To show something stays constant, we're just going to have a straight horizontal line. And then at the end of the day, the temperature increased slightly, so just a little increase before dropping sharply. So then we can make it show a steep decrease here. And that graph would represent this situation. And you're going to get to do that this week. You're going to create graphs, and you're also going to interpret graphs. So remember, anytime you have horizontal lines, that means something stayed constant. And look over here at your y-axis to see what it is that stayed constant. If it's temperature, it might be distance. So increasing, constant, increasing, decreasing. So look at those key words to help you both create a graph and then also use those keywords to interpret a graph as well. You can also work backwards from a graph and create a situation up that would represent the graph. So I'm going to go on to the next slide, so if you need more time, go ahead and click pause. So the graph that we saw, by the way, on here, on this previous slide, we would call this a continuous graph because we never picked up our, so this is an example of a continuous graph. We never picked up, the line there's no gaps in the line. So technically we could have drawn this graph without picking up our pencil. So this is a continuous graph. Where on the next slide we have what we call a discrete graph. That's an R there, discrete graph. And a discrete graph is when you have points on a graph that are representing a situation. So let's look at an example of a discrete graph. So we can also graph discrete relationships. So here we've got the situation, Jamie is taking an 8-week keyboarding class. Notice how time is in weeks, and that's on the x-axis. At the end of each week, she takes a test to find the number of words she can type per minute. She improves each week. So this graph is showing the number, we can tell from our axes and the way that they're labeled, what is being represented on this graph. So the words per minute are being tracked over 8 weeks. So each week she graphs and says week 1 she could type 20 words per minute. We look at week 5, we can see that she jumps up to like maybe 37 words per minute. And week 7, she's up to 45 words per minute. So this is a discrete relationship where it's not continuous. It's each point represents a certain amount. And anytime you see points graphed, you know that you've got a discrete relationship. You've graphed discrete data, and you'll see some examples of that this week. I'm going to move on to functions. So this is actually from Unit 2, Session 2. You're going to be introduced to functions, and functions are a way of relating our input values with our output values. So your input values are always going to be your x values, and your output values are always going to be your y values. So think of it as like you dump one number in and you get another number out. So you put your input in and you get your output out. So what makes a function special? What makes an equation a function? So a function will not give back two or more results for the same input. So what that means is if you put in the value x, let's say you put into your machine a 2, and then the output would be 1, it could only be 1. So if you put in the value of 2 for your input, you're only going to get one corresponding output. So a function is a set of ordered pairs in which each xput only has one specific y output. So again, for every input, there's only one output, and that's going to make more sense. Just hang in there with me. So one way that we can tell if relations are function is by looking at a mapping diagram. So here on the left, these are my x values or my inputs, and then here on the right are my outputs or my y values. So in order to be a function, the inputs can only have one output. And in this case, each number in our inputs is linked with only one number in our outputs. So that would make this a function. And then we can also go from the mappings and create some ordered pairs. So remember, this oval over here is our input or x values. So an ordered pair would be 0, and then the corresponding y value would be 5. And we could keep going like this. The x value right here is 1, and it links up with the y value of 4. And then we've got 2, which is linked with that 6, and 3 is linked with that 7. So that would be our ordered pairs from that mapping diagram. And because each of our x values only links up with one y value or one output, that makes it a function. I'm going to go on to the next slide. If you need more time taking notes in your math notebook, remember, click on pause. So here's a new mapping diagram where we've got a new set of, a new relation between our numbers. And we need to decide if it's a function. So let's decide first if it is a function. So remember, each of our inputs can only have one output. So let's look at 2 here. So 2 is linked with both 1 and 2. So here we see that this input has 2 different outputs. So 2 can be paired with 1, and 2 is also paired with that output of 2. So because this one input has 2 different outputs, this is not a function. So here's an example of where we have. So here, let's continue with our ordered pairs. 4, we've got 6 with 4. We've got 10 with 6. So these are our points. So another way that we can tell if a relation is a function is by looking at the ordered pairs, looking at your ordered pairs or your coordinates. And if you ever see that you've got an x value, like here I see I've got 2 different x value or 2 coordinates with the same x value, and then there's 2 different y values that it's linked to. So anytime you see in a list of ordered pairs, if you've got 2 coordinates with the same x value, and then they're linked with 2 different y values, you know then that that's going to be not a function. So you can tell if a relation is a function by looking at a mapping diagram or by looking at the ordered pairs to see if they are a function or not. We can also determine our domain and range from graphs. So you're probably looking and you're seeing 2 new words, domain and range. So before we talk about how to find these, let's talk about what they are. So when we talk about the domain of a relation, we're talking about all the possible x values. So think about that. When we've got an ordered pair or coordinate, our x value is right here, our y value is right here. The x value always tells us the horizontal movement, and the y coordinate tells us our vertical movement. So domain is all the possible x values, where the range is going to be all of our possible y values. So write this down in your math notebook, that domain is our x values and range is our possible y values. So we can look at a graph and determine all of our x values and y values, or our domains and ranges. So let's go ahead and change this to blue, this domain. So we're going to have blue represent the domain. So it's our possible x values. And remember, the x values always tell us if we're going right or left, the horizontal placement. So what can our possible y or x values be in this graph? So when we're talking about the domain and our possible x values, we're talking about the horizontal possible coordinates. So starting here on our graph and moving over to here where our graph ends. So our graph ends down here. So that would be the last possible x value. So we can see that our x values can range from -3 all the way to +1. So our domain can be anywhere from -3 to +1, but we need to write this in correct math notation. So remember, look, we've got an open circle here, so let's use an inequality. Let's be more, use better math to describe this. So we've got an open circle here, so we know that the x value has to be greater than -3. It's not going to be greater than or equal to because we do have that that open circle at the -3. Then we move over and we look at the furthest we can go to the right here is at 1. So that means our x value has to be less than or equal to 1 because the circle is closed here, telling us we can include that value of 1. So the domain, our x values, can be anywhere greater than -3 and less than or equal to 1. So that's our domain. Now what about our range? What about our range? Let's do this in red. So what about our range? So the range is our possible y values. So remember that tells us up and down. So the range is our possible y values, the up and down, the possible places we can be vertically on this graph. So we are the furthest down we can go is at -4, and then the highest we can go is to 0. So again, we're focusing on our y values for our range. So, whoops. So the range, the smallest value we can have, it looks like, is at -4, and it's a closed circle, so the y value would have to be greater than or equal to -4. And then we've got that open circle here, so it's going to be less than 0. So we're going from 0 to 4, right? 0 to 4, or to -4. -4 to 0, I should say. Ooh, that got crazy. -4 to 0. And the correct way to write this is with an inequality. So we would describe the range with an inequality of our possible y values. So we've got our domain and our range, and you'll get more practice with that this week. Lots of lessons on there. We want to write our domain and range with inequalities, just like we did here. I'm going to go on to the next slide, so if you need more time, go ahead and click pause to take notes. Otherwise, it's time for our key phrase assignment. So I mapped a relation, and I want you to tell me if that relation below that's mapped is a function, and then tell me why or why not. The directions are below if you need a reminder of how to do the key phrase assignment. That's it. And if you need any help with any of the assignments this week, let me know. Remember, I'm here to help. Otherwise, have a fantastic rest of your week.